Hey there, and welcome back to the Abacus 11 Plus channel. Today, we've got another video for you. We're going through Blackheath High School's 11 Plus maths paper. So this again is a real past paper that was given to previous 11 Plus students. So we're going to go through this paper. We're going to work out the best way to answer each and every single question so you can apply all these learnings to your own 11 Plus maths exam, which will boost your scores. So without any further ado, let's get into these solutions. Okay, so here to start off this paper, we've got a nice, easy opener. So here it's just times tables. If you know your times tables, you will get through this question very easily. The main thing is just not making any silly mistakes. So let's go through this multiplication grid. And let's start here. We have 8, and we know 8 is 2 times 4. We know 14 is 2 times 7. 24 is 4 times 6. Then we have 6 here and 7 here. What's 6 times 7? 42. 28 is 4 times 7. So here we have all the answers. 4, 7, 6, 42, and 7. Okay, and now for question 2, we're told that we need exactly 1 liter of water. But the measuring jug that we have only holds 400 milliliters when full. So how can we use this measuring jug to reach this goal of 1 liter of water? Well, first thing here, we need to understand that to answer this question efficiently, we need everything under the same units. So here we have 1 liter, but here we're talking about milliliters. So let's first convert this 1 liter into milliliters. And how many milliliters in 1 liter? Well, it's going to be 1,000. So 1,000 milliliters. And now this question seems a bit easier because we're trying to work out how many 400 milliliters go into 1,000 milliliters. Or in other words, how many jugs do we need to fill up to hit that 1,000 milliliter goal? It's simple division here. So here we can just simply take out the common factor of 100 or cancel out these two zeros on numerator and denominator. Then we have 10 divided by 4. Take out the common factor of 2, giving us 2 and 5. So we have 5 divided by 2, or just 2.5. So how can we use this measuring jug to obtain 1 liter of water? Well, we're simply going to fill it up 2.5 times, or 2.5 times. And your answer should look something like this. If you fill up the jug 2.5 times, 2.5 times, we will reach our 1,000 milliliter, our 1 liter goal of water. Okay, so here for our next question, we have some sequences and we need to fill in the next 2 numbers. So this is all about recognizing the patterns, right? We're going to try and work out the patterns, or the thing that links these numbers together, the first 4 numbers together. And then we're going to use that pattern to work out what the following numbers should be. So this first one, part A, 3, 5, 7, 9. Okay, here it's simple addition. Each time we're simply adding on 2, right? 3 plus 2 is 5, plus 2 is 7, so on and so forth. So we continue that pattern. We'll put it in blue. 9 plus 2 should give us 11. Then 11 plus 2, same pattern, should give us 13. And then for B, we have 5.1, 6.3, 7.5, 8.7. Here, it looks like it's still basic addition. These are the easiest patterns to recognize, except this time we have a decimal part. So instead of adding 2, we're adding 1.2. 1.2, 1.2. 0.2. So now continue that pattern yet again. What do we end up with? Well, if we add 1.2, we have 9.9. And then we add again 1.2, we have 11.1, right? Because a 0.2 takes us from 9.9 to 10.1. And then the additional 1 brings us to 11.1. Okay, now we have part C, 1, 3, 9, 27. Here you should recognize that the numbers are getting kind of big, kind of quickly, right? We were at 1, then suddenly we're at 9, and now suddenly at 27. The numbers are getting big quickly. And whenever we see this kind of thing happening, it gives us some sort of indication, some sort of clue that there's going to be some multiplication involved. And that's exactly what's going on here. Each time we're multiplying by 3. So here, times 3, times 3, times 3. So here, we're going to need to continue that by multiplying 27 times 3. So here we can use mental maths. I always talk about the importance of mental maths and how it can make us get through our papers quicker and be used as useful estimates before we work it out properly. So how can we use mental maths here? Let's try and think about it. 27 times 3. Well, we could say that actually 27 is very close to 30. We know 30 times 3, right? 30 times 3 is just 3 times 3 times 10. We know 3 times 3 is 9. So 30 times 3 is 90. Okay, so 30 times 3 is 90. But then we're not timesing 30 by 3. We're multiplying 27 by 3. So it's 3 lots of 3 less. So instead of it being 90, it's going to be 90 minus those 3 lots of 3 that we don't actually have. So 90 minus 3 times 3, which is 9, so 81. So 81 is the answer. And the same answer you would have gotten if you did it the long-winded way. So here, 1 carry the 2, 3 times 2 is 6, plus the 2 is 8. So here you can see how mental maths can help us answer this quicker. And then we have 81 times 3. Well, here, 80 times 3 is what? 240. You know your 8 times table, 8, 16, 24. So 240. And then 1 times 3 is 3. So 240 plus 3, 243. 243. And that is part C done. Now for part D, we have again multiplication, but this time we're multiplying by 2. So 0.3, we're doubling it. 0.6, 1.2, 2.4, 4.8, and then 4.8 doubled, 9.6. Here, 4 doubled is 8. 0.8 doubled is 1.6. Add those together. What do you get? Boom, 9.6. Okay, and now let's do E. So here we have some subtraction going on. So 15 to 11 minus 4, minus 4, minus 4. Continue that pattern. -1, -5. So those are our answers. Okay, so here for part A, we have different sums we have to add up. So here, Naruka buys a pen costing £4.93, then 24p for a pencil, then 58p for a ruler. So let's add these up. £4.93, 24p, 58p, right? Notice how some of these are in pounds, some of these are in pence. Very important to not make a mistake on. So how much did she spend altogether? Let's simply add these up. 3 plus 4 is 7, plus 8 is 15. So 5, carry the 1. Then we have 10, 12, 17, carry the 1, and then 5. So £5.75. £5.75. And then we're told she paid for them with a £20 note. So how much change did she get? Well, the change will simply be that £20 minus how much she actually was charged for all the items. So £5.75. So how can we do this? We can use our mental maths here and split it up into two different subtractions. Why? Because we know £5.75 in our head, right? It's just £5 and then 75p. So we can start by doing £20, right? Minus the £5, which is £15. Then we have £15 minus 75p, which is £14.25. And this is way quicker than doing column subtraction here, although it will give the same answer. Okay, so £14.25. Okay, so here we have a question and we can see a graph showing the number of buses passing the school each morning. And we see you have a key here. So we're told that each bus equates to, right, is equal to 20 buses. So each bus on this pictograph is equal to 20 buses in real life. So part A, we've already given it away. What is the name of this type of graph? This is a pictograph. Part B, how many buses were there on Thursday? So Thursday, first thing we do, go down to the Thursday row right here. How many buses were there? Well, here on our pictograph, we have 1, 2, 3, 4 buses, right? But each bus is equal to how many buses in real life? 20. So we have 4 on the pictograph times 20, what each bus actually represents. And that should give us 80 buses on Thursday. And then for Tuesday, same sort of thing. 1, 2, 3, 4. But then we have a half of a bus here. So here it's going to be 4 times 20, which is the 80. And then we have 1/2. So we have 10 buses. So 80 plus 10. Because think about it, if a full bus, a full picture is 20 buses, then half of that picture is going to be half of 20 buses, which is 10 buses. So here it's 20, 40, 60, 80, 10. So 90 buses. Now we're told on Friday there were 60 buses and we have to add this information to the graph. So this should be pretty straightforward for us. 60 buses, each bus is worth 20. So let's do a very bad drawing of a bus here. Got some wheels, something like this. And we're going to do this 3 times. Okay, third one. Luckily, you're not graded on the quality of your bus, but rather getting the number of drawings and number of buses correct. So it should be 3 pictures of buses, and that is the answer. So, part E, how many buses were there in total over the whole week? So Monday to Friday, we're going to add everything up. So we can actually use this convention, use this thing we've been doing, and apply it to everything else Monday to Thursday. Because once we know the number of buses or the number of pictures, we can simply multiply that by 20 to give us our answer. So here, Monday, we have 1, 2, 3, 4, 5. So let's put a 5 here. Here we have 1, 2, 3, 4.5. So let's put 4.5 here. Here we have 2. Here we have 4. Adding these up, we have 5 plus 2. We'll come back to this one later. So 5, let's put it in red. 5 plus 2, which is 7, plus 4, which is 11, plus 3, which is 14. And then we have 14 plus 4.5, which is 18.5. So 18.5 times 20 should give us the total number of buses over the whole week, Monday to Friday. So here we can do 18 times 20 and then 0.5 times 20. So 18 times 20, well, what's 18 times 2? That should be a bit easier. 18 times 2 is 36, right? Doubling 18. But then it's not 18 times 2, it's 18 times 20. So it won't be 36, it will be 36 times 10, 360. So we have 360, and then we have 0.5 times 20, which is half of 20, 10. So we have 360 plus the 10, 370. So it should be 370 buses over the entire week. And that is our answer. Okay, so here we have some lines of symmetry that we need to draw on to each pattern. Now remember how lines of symmetry work. The whole point here is we have a line of symmetry, the best way to think about it, if we can fold the pattern, fold the shape on that line, and both sides of the fold would be the same. So there'll be no overlap, there'll be no difference in both sides or in either side of the pattern. So let's show that with this first pattern. If we take this line here, this would be a line of symmetry. Why? Because this side, if we envision it, could be folded over onto the other side, and every single part of this side would line up with the other side. So this little pattern here would line up perfectly with this pattern here. This section here would line up perfectly with this section here. If we folded it over, the two sides would fit together perfectly. They would both look the same. And that's how we know we have a line of symmetry. Or in other words, they're reflections of each other. So using that understanding, let's go to this next pattern. We have a line of symmetry here. We could fold it over and it would look the same. Same thing here. Same thing here. And same thing here. These are all lines of symmetry because we can fold the shape, the pattern over, and both sides would be the exact same. They're almost like reflections of each other, or they are reflections of each other. And then here we have to be careful. But again, we have a line of symmetry here, right down the middle. A line of symmetry here, right down the middle. And these drawings, of course, aren't perfect. In the exam, use your ruler. And in fact, let's use a ruler here. Let me take my own advice. If we actually get it spot on, we have a third line of symmetry right here. So those are our lines of symmetry. Okay, so here we have a question centered around division. We have some first class stamps costing 27p, and we have Lola, who has a £5 note. So part A, how many stamps can she get with that £5 note? Well, here it's going to be a simple division, right? We have £5. Each stamp costs 27p. So how many lots of 27p can go into the £5 note, or can go into the 500p that we have? So that first thing that we did is very important, converting the pounds into pence, right? Yes, we have £5, but this is 500 pence. And we are dividing this 500 pence by 27 pence. So here, 27 goes into 50 once. And how much do we have left over? Well, it's going to be 23, because 3 gets us to 30, and then 20 to 50. We can bring down this 0. How many 27s in 230? Well, it's not going to be 10, right? Because 10 is going to be 270. And it's not going to be 9 because it's not going to be enough. So let's say around 7. If it's 7, that will be 9, 4, and then 2 times 7 is 14, or 189. So probably can add one more in there. 216, and that seems to be the most we can do. If we try and make it times 9, what's going to happen? Well, 13. Yeah, we're over. So here, multiplying it by 8 is the most we can get into 230. So here we have 216. And if we do the subtraction here, we have 0 minus 6, which we can't do. So we take a 10 from the 3. 10 minus 6 is 4. 2 minus 1 is 1, and then 0. So let's clear this up. 27 goes into 500, 18 whole times. And then we have a remainder of 14. So to answer the question, how many stamps can she get? Well, she only has enough money to get 18 stamps, the whole part of this division. Because you can't get a part, a fraction of a stamp. You can only get a whole stamp. And then part B, we've already kind of worked out how much money did she have left. Well, it's going to be the 14p, the remainder. So it's going to be 14 here. And then part C, explain why your last answer must be less than 27p. Well, we kind of touched on it already. This 14p or whatever it is has to be less than 27p, because if it was 27p or above, we would have used that money to buy another whole stamp. So if we're saying the maximum number of stamps she can get is 18, that means we've maxed out all the lots of 27p that we have. So whatever we have less has to be less than 27p. So how can we put this into words? Explain why your last answer must be less than 27p. Because if Lola had 27p or more left over, comma, she would buy another stamp. Simple as that. Let's move on to the next question. Okay, so here we have another question, and this tests our understanding of different definitions within maths, which we need to know for our exam. So starting off pretty easy. Part A, from these numbers, which one is an even number? We know odd, even numbers, so this should be pretty easy. It's going to be 22. 22 is our even number. Okay, part B. Let's find a multiple of 9. So multiple of 9 means it's going to be in the 9 times table, and it's going to be bigger than 9, right? Multiples go up, factors go down. So if we think about it, 9 times 1 is 9, 9 times 2 is 18, then we have 27, 36, and I think we should have already gotten to one of the answers, or gotten to the answer, which is 27. As a multiple of 9, right? So by multiple of 9, we mean a number that can be divided by 9 and it will give us a whole number. So 27 can be divided wholly by 9. And then for part C, we have a square number, and this is going to be 25. And that's because 25 is the result of doing 5 times 5, or 5 squared, multiplying 5 by itself. So 5 times 5, 25. And then we have D, a factor of 87. So now factors go down. So for this, we're trying to work out the numbers that go into 87. So here, if we think about it, if we have 87, what numbers can we multiply together to give us 87? Well, it could actually be 29 and 3, because 20 times 3 is 60, and 9 times 3 is 27. And 60 plus 27 is 87. So here we know that 29 is a factor of 87 because 29 goes into 87 3 times. And then we have a prime number. So important definition wise, a prime number will have 2 factors. So we just talked about factors here. Prime number has 2 factors, right? Itself and 1. Itself and 1. That's why 1 is not prime, because 1 only has 1 factor, itself. Because itself is the same thing as 1. So 1 is not a prime number. Our first prime number is going to be 2, because 2 can be divided by itself and 1. So here, let's find a prime number. It's going to be 23. Why? Because 23 only has 2 factors, itself, 23, and 1. No other number can go into 23. And finally, for part F, we have a triangle number. And again, for our 11 plus exam, we need to understand what triangle numbers are. And they're not that complex, thankfully. All they are numbers related to building an equilateral triangle. That's the best way to think about it. So here, we have an equilateral triangle, one here, second one here. Can we see that we have equilateral triangles, right? But can you also see the number of blocks that we need to make up these equilateral triangles? For here, on this first one, we need 3 dots or 3 blocks. Then we need 1, 2, 3, 4, 5, 6. Then we'll need, if we have a base of 4, 2, 3, 4, 1, 2, 3, 1, 2, 1. It's going to be how many? Well, 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So you can see that as we get bigger and bigger and bigger, we need more dots to make that equilateral triangle. And the number of dots represents our triangle numbers. But you can also see how they're kind of going up in a consistent pattern. 3 to 6 is plus 3. 6 to 10 is plus 4. Then it's plus 5, so on and so forth. So those are our triangle numbers. That's how triangle numbers work. And it's something we just need to know. But as you can see, once you understand it, it's not too complex. The triangle number here is 21, which is what we get when we try and make our 5th equilateral triangle. Okay, so here for question 9, we have to fill in these spaces to make all of these fractions equal. So what we have to do here is we have to start on this fraction, because this fraction tells us what we have to turn all these fractions into. Because this fraction here, 2 over 6, shows that we want all these fractions to equal to 2 over 6, which is 1 over 3. Or in other words, the best way to think about this is when we have 1 over 3, this is simply a scenario where the numerator, remember top is numerator, bottom is denominator, Now we want a scenario where the denominator is 3 times the size of the numerator. And once we understand this, it makes this question super easy, because all we have to use are our times tables. Because for this first one, it's going to be 1 over 3. We know that already. Then for this third one, it's going to be 18. Well, what times 3 equals 18? It's going to be 6. 6, 12, 18. Then here, we times it by 3, 21. 7, 14, 21. Here, we divide it by 3, giving us 20. 20, 40, 60. So here we have our answers. All these fractions are now equal. Because yes, although they're different numbers, we can cancel them down to 1 over 3. Or in other words, for all of these fractions here, 1/3 is these fractions in their simplest form. Simplest form. Okay, so here for this question, what do? We have to use our ruler to measure the length and width of this rectangle as accurately as we can. So let's do this. Of course, in your exam, you use your own real ruler, but here all we have is this makeshift ruler. So let's line it up and let's see what it gives us. So let's say this is 1 centimeter, and then 2, 3, 4, 5, 6, 7, 8 centimeters. Let's call this length 8. And then the width, you'll take it, spin your ruler around, line it up, and let's see what it gives us. Here we have 1, 2, 3, 4.5. Okay, so here it's 4.5 centimeters. So that's part A done, but now let's do part B. Use your answers to work out the perimeter of the rectangle. So no matter what numbers you got, you might have gotten different numbers, maybe 6 and 2.5 or whatever you got. Either way, we work out the perimeter the same way. Remember, perimeter is the distance around the outside of the shape. So here, all we're going to do is take our numbers. So if we use my numbers here, 8 and 4.5, 8 here, 8 here, 4.5 here, 4.5 here. So we do 8 plus 4.5 plus 8 plus 4.5 all the way around. 8, 4.5, 8, 4.5. So basically what we have here are 2 lots of 8 and 2 lots of 4.5. So 8 plus 8 gives us 16. 4.5 plus 4.5 gives us 9. Then we have 16 plus 9 giving us 25. So the perimeter is 25 centimeters. So here for this question, we see that we have to put rings around all the numbers which are equal to 75%. So this question is simply about understanding fraction to decimal to percentage conversion, right? So we need to know how to convert this percentage, 75%, into different forms. And through doing that, we'll know what it's equal to within this list. So the main thing to understand here is we need to understand percentage language. In the percentage world, in the percentage universe, the whole is 100%. The whole is 100%. So that means when we see a percentage like 75%, all this really means is that we have 75% of 100%, which is the whole in the percentage world, in the percentage universe. But you see, that gives us so much information. That's so helpful because as soon as we know it's 75% out of 100%, we can already start to see how this can become something like a fraction. Because now we take out the percentage signs, the common factor of the percentage, and we have 75 over 100, which is a fraction, the fraction form of 75%. We can then cancel down this fraction. We can take out the common factor of 25 because 25 times 3, or I'll put it in black, times 3 is 75, and 25 times 4 is 100, which means that 75 over 100 can be reduced to 3 over 4, 3/4. So that already lets us know that this has to be equal to 75%, and this fraction also is equal to 75%. But then also we know that 6 over 8 is going to be equal to 75%, because simply if we multiply the top and bottom by 2, so numerator times it by 2, denominator times it by 2, we get 6/8. So 3/4 is simply a simplified version of 6/8. The same way if it was 60/80. Again, 3/4 is simply the simplest form of 60/80. Same thing. So those are the fractions that are equal to 75%. 75/100, 6/8, which can be 3/4, and of course, 3/4, 3/4. But then we move on to decimals, right? We have some decimals, and we need to know whether or not these are equal to 75%. So now how do we go from percentage to decimal? Well, that's why it's so important to know how to first go from percentage to fraction, because once we get to fraction, we can go really easily to decimal. Because let's take 75/100. Okay, so now let's look at the rest of these numbers. We know already that 34% is not equal to 75%, so we're left with these 3 decimals. So how can we work this out? Well, again, we're going to need to use conversion. But what's really helpful is once we already know how to go from percentage to fraction, it becomes super easy to go from fraction to decimal. So let's take the fraction form of 75%, 75/100. What does this actually mean? This actually means we're taking the numerator, 75, and we're dividing it by the denominator, 100. So it's 75 divided by 100. And what happens when we have 75.075, same thing? The 0.0 does nothing. What happens when we divide this by 100? Well, the decimal point goes 2 steps back. It goes 2 bunny hops back in the left direction. And it ends up over here. So 1 bunny hop, 2 bunny hops. So now it's no longer 75.0, but instead it's 0.75, 0.75. So now this is the decimal form of this percentage, 75%. And we can see this is right here. So now we know it's not this, but this is the correct decimal that represents 75%. So here are our answers. 75/100, 3/4, 6/8, and 0.75. Okay, question 12. In her exam, Manreet got 16 marks out of 20. What was her mark as a percentage? So now, our previous question was conversion, and now we have another question on conversion. Except this time we're going from fraction to percentage. Why fraction? Because Manreet got 16 marks out of the available total 20 marks. So it's indeed a fraction we're looking at. But then how do we turn this into a percentage? Well, we simply take this fraction, 16/20, and we multiply it by 100/1. Same thing. Any number over 1 is the same thing as that number. So 16/20 times 100/1. This should bring it into percentage format. Because remember, the whole in percentage world is 100%. So 16/20, how can we work this out? Well, first we can cancel down this vertical column here. We can take out the common factor of 4, because 4 goes into 16 4 times and 4 goes into 20 5 times. Then we can cancel across this diagonal using the common factor of 5, because 5 goes into 5 once and 5 goes into 100 20 times. So if we clean this up, now we have 4/1 times 20/1, which is very simple. Multiply across the numerators and across the denominators, and we have 80 over 1, or simply 80%. That's how we work this out. Okay, now for question 13, we see yet again we have, at least for part A, another question drawing upon our understanding of fraction to decimal to percentage conversion. And that's why it's so important that we understand this for our exam. So we see the sign in the shop, 25% sale, so 25% off all marked prices. But part A, explain why 25% is 1/4 or 1/4. Why is that? Well, if you understand what we've just been talking about for the previous questions, fraction, decimal, and percentage conversion, this shouldn't be too hard. And the reason is because we understand that in percentage world, the whole is 100%. So this 25% is simply 25% of 100%, or 25% over 100%. But then this allows us to form a fraction because we have 25% over 100%. We can take out the common factor of percent. We can take out the percent sign in each number in the numerator and denominator. And now we're simply left with 25 over 100. And then if we cancel this down, so let's leave our working for the examiner so they know exactly how we're thinking about this. 25% over 100%, 25 over 100. Then we take out the common factor of 25, giving us 1/4, right? And this leads to 1/4, which is 1/4. So that's how it works. Understanding in percentage world, the whole is 100%, and 25% over 100% can be cancelled down to 1/4, 1/4. Okay, for part B, Sandra chooses a pair of jeans marked at £48. How much did Sandra save by buying them in the sale? So here, we're not working out how much she spent, but we need to work out how much she saved. Very important that we don't miss that. So to work out how much she saved, we can do two things. Number one, we can work out how much she actually spent, and then simply work out the difference between the marked price and how much she spent. Or we can do it a bit quicker and simply work out how much she saved first time round by working out the savings. Because if you're getting 25% off all marked prices, then your savings 25% for every single marked item, right? So we can work out how much she saved by simply working out 25% of £48 first time round. Now we know the magic word of simply means times, it means multiplication. So we have 25% of times 48. And we already know 25% is equal to 1/4. We just worked that out. So here we have 1/4 times £48, or 48 over 1. And we can cancel across this diagonal. 4 goes into 4 once and into 48 12 times. So this is going to be £12 in savings. And now for part C, we have how much will she actually have to pay for them in the sale. So we started off at £48 as the marked price. We're saving £12. So overall, we're actually going to pay £36. So 48 minus 10 is 38. 38 minus the remaining 2 is 36. So we're actually going to pay £36. Okay, so for this question, we are now dabbling into probability, another topic we need to understand for our 11 plus maths exams. So part A, if you throw a fair die 36 times, how many 3s would you expect to get? Well, how do we do this? Well, let's first think about the probability of rolling a 3 on a fair die. Well, on a die, or a dice, we have 1, 3. From the numbers 1 to 6, we have one of each of those numbers. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. So out of the 6 faces, we have 1, 3. So 1 out of the 6 faces. So the probability of rolling a 3 would be 1, that's our criteria, over 6, the total number available. Criteria, or number that fit our criteria, over total number available. So 1 over 6. Now, if we throw a fair die 36 times, we can work out how many 3s we're going to get by multiplying this probability by 36. So we're testing this probability 36 times by rolling it or throwing it 36 times. And now we're in familiar territory. It's simply fraction multiplication. And we simply are going to cancel or simplify across this diagonal using a common factor of 6, because 6 goes into 6 once and 6 goes into 36 6 times. And therefore, the answer is 6. We should expect to get 6 3s. Okay, and now for this part B, we have a couple of parts to this answer, but let's try and go through it step by step. First, we have to fill in this tally chart based on the numbers that Natasha got when she actually threw a die 30 times. So let's fill in this tally chart, making sure we don't make any silly mistakes. That will be the main thing to watch out for here. So we have a 3, then we have a 4, then we have a 1, a 6, a 1, 3, 4, 5, 1, 4, 4. Okay, that's the first row done. Then we have 5, 6, 3, 1, 4, 1, 5, 1, 6, 3, 1. Again, no point rushing through this. You don't want to get it wrong. 5, 4, 1, 6, 3, 5, 6, 4. Okay, done. So we're going to put in the frequencies. And to check this, how are we going to check that we didn't make any mistakes here? Well, one way is by adding up the frequencies, and it should add up to 30. So we'll make sure it does when we fill it in. So here we have 5, 6, 7, 8. We have no 2s. Interesting. Then we have 5 3s. We have 5, 6, 7 4s. We have 5 5s, and we have 5 6s. Let's add it up. 8, 5 is 13, 20, 25, 30. Perfect. Okay. So, do you think her die was fair? Well, we could say no. And it's not only about our answer, but it's about the explanation behind the answer. So an easy way to explain no, or to justify our answer, is to say this die can't be fair because no 2s were thrown. Right? We had a 0 frequency for 2s. And we could even add on when the expected frequency is 5, right? Because we have 30 rolls, and the probability of rolling a 2 is 1 over 6. So 1 over 6 times those 30 rolls should give us 5. So we should be expecting 5 of each number. And we got 5 for quite a few, which maybe could be part of an argument for why this dice is fair. Maybe if we rolled it more times, then the numbers would align more closely with this 1/6 probability. But again, it's all about how we justify our answer. We could say this dice is not fair because there were no 2s, not a single 2 was thrown, when really the expected frequency is 5. We're expecting 5 2s out of 30 rolls. Okay, so here we have a coordinates question. So let's try and dig into this right now. Point A has the coordinates 2, 1, and we can see that 2 across, 1 up. That's point A. What are the coordinates of B and C? So let's think about and remember how coordinates work. When we have these coordinates, X and Y, for example, it's telling us how far to the right and up we're going. So it's X to the right and then Y up. And if it's negative, it reverses. So left and then down. So now let's go to our question and find the coordinates of B and C. Well, for B, we're not going any across, but we're going 1, 2, 3, 4 up. So 0 across, 4 up. For C, we're going 1, 2 across, and then 1, 2, 3, 4 up. So 2 across, 4 up. That's how we think, to the right and up. Now, on the graph above, mark the points L and M. So 6, 1, 6, 5. We should be confident doing this. 6, 1 means 6 to the right. 1, 2, 3, 4, 5, 6. 1 up. So right here. And then 5 will be the same across, but 5 up. 2, 3, 4, 5, right here. So that's L. Let's put L here. And this is M. Awesome. Okay. Now mark a third point N so that the 3 points L, M, N join up to make an isosceles triangle. So we need to know what an isosceles triangle is. An isosceles triangle is a triangle where 2 sides are of equal length. And because we have 2 sides of equal length, that also means we have 2 angles of equal size or 2 angles of equal value. But for this question, the main thing we need to understand is an isosceles triangle means we have 2 sides of equal length. So different from an equilateral where every side is equal, different from scalene, different from right-angled, isosceles. So to work this out, we can simply make this triangle such that 2 sides are of equal length. So here, the difference between L and M is 1, 2, 3, 4. So if we go halfway, and then we go up across this plane, then we should get a scenario where this coordinate to our joining point, and then this coordinate to our joining point creates these 2 sides of equal length. So let's see if we can do that. So go to the middle here, and let's pick any point here. So let's pick a point here. We know that this length, and I'll put it in black, we know that this length should be equal to this length because we went halfway between M and L. And if we join it up, here is our isosceles triangle, where the 2 black lines are equal, and this line is different. So for this, our answer for N could be 5 to the right, and then 3 up. So 5, 3. But really, any of these coordinates would have worked the exact same. Apart from this one, of course, because this wouldn't make a triangle. So we have 5, 3, but N could be anything. So N could be X3, where X is bigger or equal to 0, but smaller than 6. So here, x is bigger than or equal to 0, but x is smaller than 6. And you wouldn't have to write this in the answer, but on this channel, we're going above and beyond, right? We want those top marks in the grammar school exams. We want those scholarships in the independent school exams. So this is for our own understanding, so we really understand what's going on. Any one of these points could have worked, and mathematically we can show that by saying n equals x across 3 up. And this works for any value of x where x is greater than or equal to 0, so all these ones, but less than 6. It can't be 6 right here. So if we clean this up, this is our answer. 5,3 or x3, where x is this. Okay, so here for this question, we have a shaded rectangle with an area of 12 centimeters squared. And we have to draw a different rectangle also with an area of 12 centimeters squared. And we're told rotations are not allowed. So how do we think about this? Well, first of all, we know this rectangle up here has an area of 12 centimeters squared because we have a width of 3 and a length of 4. And 4 times 3 equals 12, right? So by the question saying, or the examiner saying that rotations aren't allowed, it means we can't just flip this rectangle around and do this. But we have a length of 3 and a width of 4. We can't do that. We have to think about it differently. And all we have to do really is think about different ways to make up 12. Yes, 12 is 4 times 3, but 12 is also 2 times 6. So actually we can draw a rectangle that's 2 by 6. So 1, 2 across, and then 6, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 up. So here. And then we go across by 2, and we go down. So that is our badly drawn rectangle, still with an area of 12 centimeters squared, but this time it's 2 by 6. And then we have on this grid, draw a triangle with area of 6 centimeters squared. Well, how do we do this? Well, we know the area for a triangle is length times width divided by 2. And we want this area to equal 6. So we can rearrange this equation by multiplying both sides by 2. That cancels out this here and leaves us with the length times width equals 12, because 6 times 2 is 12. So we know all we have to do is draw a triangle that has a width or a base, same thing, base length times base, or base times height, same thing really. And the main point here is that those two numbers need to multiply to give us 12. So we can do that. We can have many combinations, but one answer could be a base of 3, 1, 2, 3, and a height of 4. So 1, 2, 3, 4. So we're going to have this triangle right here. This triangle will have an area of 6 centimeters squared. Or we can make it even a triangle like this. Doesn't really matter. As long as we understand what's going on, we know that it's going to have an area of 6 centimeters squared. Because here, base is 3, height is 4, length times width, or base times height divided by 2 gives us 6. And this also draws upon our understanding that every single triangle is simply half of a rectangle, because here we have the full rectangle, which would be here, which has an area of 12 centimeters squared. But then we half it for the triangle, giving us 6 centimeters squared. These bits of understanding really help us in our exams. Okay, so let's go through this question. We see the 4 cards that Polly has. So let's try and arrange them to get the largest possible number. So to do this, we need to start with the biggest number out of all the cards we have, which is going to be the 9. Because 9,000 is going to be bigger than 4,000 or 3,000 or 1,000. So 9,000, then we put the next biggest number, 431. We want the biggest numbers on the left, because that will create the largest possible numbers. Smallest, we want the opposite. We want 1,000. We want 349. The number nearest to 4,000, well, it's either, let's think about this. We're either going to have a number starting with 3 and then 9 and then 41 to try and get, if we have 4,000 here, we can try and approach it from the bottom, or we can try and approach it from the top and start with a number that begins with 4 and then minimize everything else. So 4139. Now we've got to think about what's the difference when we use both methods. Well, for this bottom method, bottom up, the difference is only going to be 59. We only add on 59 to get to 4,000. But for 4139, we have to take away 139, which is way more, which means the nearest number is going to be this one. This number is the winner, 3941, going from the bottom up. And now for part D, we're told that Nithana gives her a card with a decimal point on. So we have a decimal point now. How can Polly arrange her 5 cards now to get the number nearest to 50? So let's think about this. We have 50. To get close to 50, out of the numbers and cards we have, we're going to want to start with 49. But then we can use our decimal point, because right now we're a whole 1 away from 50. But we can get closer to 50 by using our decimal point and then inching a bit closer by using the 3 and the 1. Because now we're not a whole 1 away from 50, we're only 0.69 away from 50. We can add 0.69 to go from 49.31 to 50.00. So here, that's how we want to arrange our 5 cards. Get the 49, then put the decimal point to get even closer, and then get as close as possible with 0.31. So here for this next question, we need to draw on our understanding of mean, median, mode, range, all these things here. Because we're told that a ticket inspector counted how many passengers there were in each carriage of a train. And these are the results. What's the average? Okay, so how do we work out? And we have to show our working as well. So how do we work this out? The average, the mean of the number of passengers. Well, we simply take the total number and we divide it by how many numbers there are. So total over number. So if we do this and we start with the total, let's add up all these numbers. So we have 5, we have 24, 37, 45, 36, 39, 22, 16. So let's not make any silly mistakes. We should be able to get this right. So 5 plus 4 is 9, plus 7 is 16, plus 5 is 21, 21 plus 6 is 27, plus 9 is 36, plus 2 is 38, plus 6 is 44. And then 6, 9, 13, 16, 19, 21, 22. So 224 is our total. And then how many numbers are there? We have 1, 2, 3, 4, 5, 6, 7, 8 numbers, or 8 carriages. So now if we take 224 and we divide it by 8, it will give us the average number of passengers for every single carriage. So let's do this division. 224 divided by 8, or 8 goes into 22, 2 times wholly, 16, giving us 6 left over. And then 8 into 64 is 8. 8 times 8 is 64, right? So 28 is our mean number of passengers per carriage. And then for the range, it's quite simple because all we're doing is taking the biggest number and subtracting the smallest number. So let's identify those numbers. The biggest looks like it's 45, and the smallest looks like it's 5. So 45 minus 5 gives us what? 40. So 40 is our range. And now for part C, we have, she worked out that the median number of passengers was 30. Show what working she used to get this answer. So we need to understand how to work out the median. And the main thing with the median that most people get wrong, the number one silly mistake, is forgetting to order the numbers. We have to order the numbers. So let's do that and try and get it right. 5. Next is 16. Next will be 22, then 24. What's next? It's going to be 36, 37, 39. And finally, we have 45. Okay. So now that we've ordered the numbers, we can cancel them out from each side to try and find the middle number. That's what median means, the middle number. Okay, so now the middle numbers we have are 24 and 36. So we want to find the middle of 24 and 36, which we can do by adding these two numbers together and then dividing by 2. So 24 plus 36 is going to be what? Well, 20 plus 30 is 50. 4 plus 6 is 10. So 50 plus 10 is 60. So 60 divided by 2 is 30, which is why the median is 30. That's her working out. Okay, so now we have some shape reflection questions. So we have this shape here, and we're going to reflect this in this mirror line. So best way to do this is to do it point by point. So here, it's 1 away, so we put 1 away here. Same thing here, 1 away, and then 1, 2, 3. So 1, 2, 3 here. Okay, clean it up and join up these points, and we should get the reflected shape. So 1, 2, and 3. Okay. And then to get it completely correct, the line should be also going away from the mirror line, away from the mirror line. So like this. This is the correct reflection of this shape. And same thing here for part 2. But now we have a slanted mirror line, so we have to be very careful. Well, we know we can simply go across like this, put our first point here. But then for this point here, it's 1, 2, 3 from the mirror line. But because we're slanted, we're not going to go this way. We're going to go downwards. So it's going to be 1, 2, 3 from the mirror line. Same thing here. If it's 1, 2, 3, 4 from the mirror line, we're not going in the same direction. We're going this way, towards, inwards. So 1, 2, 3, 4 here. And if you're struggling with that, in the exam, there's no rule that says you can't simply turn your page. If you can visualize these things better when you have a vertical mirror line, then simply rotate your page in the exam or rotate the paper, and then you have the vertical line, the vertical mirror line, and simply map across each one of the points, and you'll get the right answer. Join these up, and here is our reflected triangle, and then let's make it completely correct by adding in the lines. So here is our answer. Okay, so here for question 20, we have some patterns, and we're making these patterns using matchsticks. So Anna, these are the first 3 patterns she makes with matchsticks. 1, 2, 3. And we have to draw pattern 4. So let's try and see what's going on and try and recognize if there's anything going on here that we can use to help us. Well, it seems to be triangles that she's making with these matchsticks. And every single time we go up a pattern by 1, we're adding on 2 triangles. So 1 triangle here, 3 triangles here, 5 triangles here. So really we should be expecting 7 triangles for our pattern, pattern number 4. So let's try and draw this in. So we have 1, 2, so that's 1. And then we have the next one. For this, we can simply copy what we have here already. And then we bring it back again. Just copying pattern 3 so far. Okay. So that's pattern 3 with the 1, 2, 3, 4, 5 triangles. But now we need to add on 2 more triangles. So put this one here, put this one here, and then the last one. Okay, so not as well drawn as the examiner, but the point still stands clear. We have 7 triangles, 1, 2, 3, 4, 5, 6, 7. This is pattern 4. And then we fill in this table: shape, number of triangles, number of matches. Okay, so let's fill this in. This should be very helpful. So shape 1, number of triangles. So pattern 1, 1. Number of matches 3. And then let's move on to shape or pattern 2. Number of triangles 3, 1, 2, 3. Number of matches, well, 1, 2, 3, 4, 5, 6, 7. Okay. Pattern 3 has been done for us. 4 and 5, let's try and fill it in. Well, let's look for the pattern within the patterns. Number of triangles, 1, 3, I'll put it in red. 1, 3, 5, something, something. It's going up by 2 every single time. As we already said with the number of triangles, every single time we increase and go to the next pattern, the number of triangles increases by 2. So 7, 9. Number of matches. Well, here we're going up by 4 each time. So it seems like this should be 15 and then 19 because the number of matches are going up by 4. Okay, now we've done that, let's answer this question or these questions. In shape 6, how many triangles will there be? Well, let's simply work it out. The pattern will continue. For shape 6, we're going to have 11 triangles because we add 2 each time. And then we're going to have 23 matches because we add 4 each time. So there'll be 11 triangles and there'll be 23 matches. In shape 100, how many triangles will there be? Explain how you work this out. Okay, so now we're on to shape 100. We can no longer manually write out 8, 9, 10, all the way to 100 because that will take up way too much time and you will not finish before the exam is over. So instead, we have to look at a formula. We have to build a formula that links the number of shapes to the number of triangles and the number of matches. So let's think about this. How can we do this? Well, Let's focus on triangles first, and then we'll build a formula for matches. Let's first look at the relationship between shapes, okay, this row, and triangles. That's how we're going to build the formula, by looking at the relationship between those two things. So shape 1, we had 1, I'll put it in. Let's use a fancy green, right? Shape 1, we have 1 triangle. Shape 2, we have 3 triangles. Shape 3, we have 5 triangles. Shape 4, we have 7 triangles. Okay, so what's going on here? You might be able to see a pattern in that to work out the number of triangles, what's going on here is it's almost like we're doubling the shape number, doubling it. So this times 2 is 2, and then we're minusing 1. So for shape 1, we're doubling it or timesing by 2 to get 2. And then we're minusing 1 to get 1. Same thing for shape 2. To get the number of triangles 3, we're doubling 2. So 2 times 2 gives us 4. And then we're minusing 1 to give us 3. Same thing for 3. We're doubling 3 to give us 6. And then we're minusing 1 to give us 5. So it seems like whatever the shape number is, we're doing the shape number in general times 2, doubling it, and then we're taking away 1 from that result. So shape times 2 minus 1, shape times 2 minus 1, shape times 2 minus 1, shape times 2 minus 1. So this could be our formula. Triangles, or T, which stands for triangles, nothing fancy. T, triangles, equals shape number times 2 minus 1. So in shape 100, how many triangles will there be? Well, T, triangles for shape 100 will be 100 times 2 minus 1, or 200 minus 1, or simply 199. So 199 triangles. That's how we can work it out. And now we're sort of moving into nth term territory, which is again another topic that we need to understand for our 11 plus exams. Okay, part D, same thing now, but for matches, for shape 100. Well, here there are many ways we can work it out. We could try and work out a relationship between shape and matches, just how we did for shape and triangle. Or we can simply work out a relationship between triangle and matches, which may be easier because you've already done all the work to work out how many triangles they're going to be. And this shouldn't be too hard, because going from triangles to matches, it seems like all we're doing is timesing by 2 and then adding 1. So 1 times 2 is 2, add 1 is 3. 3 times 2 is 6, add 1 is 7. 5 times 2 is 10, add 1 is 11. 7 times 2 is 14, add 1 is 15. 9 times 2 is 18, add 1 is 19. So it's simply triangles times 2, add 1. So here, we've already got the number of triangles for shape 100. It's 199 times 2, add 1. Now, 199 times 2, well, what's 200 times 2? 199 is so close to 200. 200 times 2 is 400. Then we're taking away that 1 times 2 that we don't have, which is 2. So 400 minus that 2 is 398. Add the 1, 399. And that's part D. Finally, for part E, we're told Anna makes a shape with 29 triangles. So how many matches did she use? Okay, so now we have a relationship between triangles and matches. Now we've already worked this out. That's what we did in part D. We know already that matches equals triangles times 2 plus 1. So now we're told she uses 29 triangles. So the matches will be 29 times 2 plus 1. Now, 29 times 2, 30 times 2. Again, mental maths will always save us. 30 times 2 is 60. Minus the one we don't have is 2. So 1 times 2 is 2. 60 minus 2, 58. 58 plus 1, 59. So 59 matches. That's how we answer this question. A longer one, but if you understand what's going on, you can get it right every single time. Okay, now here for our final question, we're told that Siobhan has lots of 2p stamps and plenty of 5p stamps. Show how she could use them to pay for postage of amounts from 81p to 99p. The first one is done for you. Okay, so we see the one done for us, 81p, is made up of 15 times 5 plus 3 times 2. So let's work that out to verify. 15 times 5, well, 10 times 5, 50. 5 times 5, 25, so 75. Plus 3 times 2, which is 6, so 81. Okay, so if we have lots of 5p stamps and lots of 2p stamps, then one of the advantages of having 5p stamps is that 5s, when we group them together, 5p, every second 5 gives us a number with 0 on the end. So 5, 10, 15, 20, 25, 30, 80, 85, 85, 90, 95, 100, right? So we can use that fact to help us out here. So for 82, we can simply get to 80 and then add 2. And then for numbers that are odd, like 83, and we can't do that, instead we can go to 75 and then add on the remaining 8. So that's our strategy. If it's even, then we get to the whole number, or in other words, AKA get to the 0, and then we add on some lot of 2. So add on x times 2, some lot of 2. If they're odd, what do? Well, we go to the 5, aka a number ending in 5, and then we add on some lot of 2. That's our strategy. Let's try and see if that works. So 82 even. So let's get to a whole. So how do we get to a whole 80 with 5p stamps? We multiply it by 16. 16 times 5 gives us 80, plus 1 times 2 gives us 82. So that will be 16 5p stamps and 1 2p stamp. 83, we go to 75, which is 15 times 5. Then we add on 8, which is 4 times 2. 84, again, we're going to go to 80. So 16 times 5. Then we're going to add on 2 times 2. So 80 plus 4. Here, for the 85, well, that's a multiple of 5. So we can simply multiply 5 by how many? 17. "17 times 5 should give us 85, because 10 times 5 is 50, 7 times 5 is 35. 50, 35, 85. That's all we need. And then 86. So here, let's go to 80. So we'll do 16 times 5 to get to 80. And then we're going to add on the remaining 6. So 3 times 2. 87. Well, now we can go to 85 as, the number ending in 5. It's an odd number. Go to 85 with 17 times 5, then add on 1 lot of 2. 88 Well, here we're going to go to the 80, 16 times 5, add on the 8, so 4 times 2. 89, we're going to go to 85, 17 times 5, add on the 4, 2 times 2. 90, multiple of 5. We can times 5 by 18, so 18 times 5. 91, we're going to go to 85, so 17 times 5. Add on the remaining 6, so 3 times 2. 92, we're going to go to 90. 18 times 5, it's ending in 0. Add the 2 we need, 1 times 2. And you can see how this is going. So let's just complete it and don't make any silly mistakes. So 93, we're going to go to 85, so 17 times 5. Add on the 8, 4 times 2. 94, we're going to go to 90, which is 18 times 5. We're going to add on 2 times 2, which is 4. 95, multiple of 5. This should be 19 times 5. 96, go to the 90, which is 18 times 5. Add the 6, 3 times 2. 97, go to 95, 19 times 5. Add the 2, 1 times 2. 98, well, we're going to go to 90, which is 18 times 5. And then we're going to add on the remaining 8. So 4 times 2. 99, go to 80 or 95. 19 times 5. Add the 4, 2 times 2. Okay, there we go. That's our answer. And if you're careful, take your time, and you don't make any silly mistakes, you should get it completely correct. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.